This video is to review the 4 types of angles that can be found with circles. So the first is a central angle. So in a central angle, your angle is going to be equal to the measure of the arc. So in number 1, we have an angle is 51 degrees, which means the arc is going to have the same measure of 51 degrees. In number 2, our arc is 79 degrees, so our angle has the same measure as 79 degrees. In number 3, we don't know the arc between CB yet, but we do know the arc going the longer way around the circle is 272 degrees. In a circle, there is a total of 360 degrees. So we can subtract 360 minus 272, and we get that this arc is 88 degrees, which means the angle is also 88 degrees. The second type of angles inside of a circle is an inscribed angle. So an inscribed angle has the vertex of the angle somewhere on the circle. And there's 2 types of cases here. So we can have one where it's created by 2 chords or a chord and a tangent. So in this case, our angle is equal to half the arc. That's why we see if the arc is 2x, half of that would make the angle x in both cases here. So in number 2, we know that the angle is 31 degrees. We want to get the arc, so we're going to multiply 2 times 31 to get 62 degrees. In number 2, we see that CU and UB are congruent chords, which means the arcs are also congruent, both at 121 degrees. We want to know what arc CB is, so we can subtract from 360. So we get that our arc is 118 degrees. To get our angle, we are going to take half of 118. So that angle would be 59 degrees. In number 3, we have the arc is 96. To get our angle, we're going to take half of 96 degrees. So our arc would be 48. In number 4, we have the angle. So to have the arc that the angle is intercepting, we would double that angle. So 2 times 42 would get us 84 degrees. But we're looking for x, which is on the other part of the circle that was not included in that arc. So we can do 360 minus 84. And we get that x is 276 degrees. The third type is an angle that has a vertex inside the circle. So if this is our angle, it is intercepting 2 arcs. To get the angle, it is equal to 1/2 the sum of the arcs. So we're going to add arc plus arc. Remember that the angle is always by itself. It doesn't matter where the variable is. So sometimes the variable will be by itself. Sometimes the variable will be in the parentheses. So in number 1, we have an angle that is x. So x is equal to 1/2 arc plus arc. So 52 plus 106. So we get x is equal to 1/2 of 158. So x is 79 degrees. Now, in number 2, our angle is 101 degrees, and it is equal to 1/2 arc plus arc. So the arcs here are x and 142. Because we are solving for x and it's in parentheses, to get rid of the half, we are going to first multiply both sides by 2. The 2 and the half cancel out, so we get 202 equals x plus 142. Then we can subtract 142 from both sides, so we get x is going to be 60 degrees. The last type of angle is when the vertex is outside the circle. So these are 3 examples of what this could look like. So in each time, our angle is going to be outside the circle, and it is intercepting 2 arcs. So there's always a smaller arc that is closer to the angle and a further arc that is farther away from the angle. So when the angle is outside the circle, we are going to subtract the arc. So for all of these situations, our angle is going to equal 1/2 arc 1, which is the further arc, minus arc 2. So when you subtract your arcs, you should still always get a positive number. So in number 1, x is going to be our angle. So we have x equals 1/2 of our further arc away from the angle, so 174 minus the closer arc of 22. So when we subtract, we get x is equal to 1/2 of 152. When we divide by 2, x is going to be 76 degrees. Now, in number 2, the angle is 18, so we're going to put that by itself, equals 1/2 the further arc minus the closer arc. Again, to get rid of that half, we're going to multiply both sides by 2, so the half and the 2 cancel out. 36 equals 114 minus x squared. We can subtract 114 from both sides, so negative 78 equals negative x. Divide by negative 1, so x is 78 degrees. Remember that x should always come out positive because it's representing an angle measure.